Hello guys, very welcome to my YouTube channel. My name is Shambhu and today I'm going to discuss about MPLS traffic engineering that I have configured in this particular network you are seeing on this GNS3 topology. Basically, I have so many things configured in this topology like MPLS VPNs, basic MPLS LDP, etc. is also configured, and then I have MPLS traffic engineering as well. I have written blogs on the basis of this particular topology on my blog. You can go visit protocoholic.com and you'll see that there are some 8 to 10 blogs on the basis of this particular topology. So I have integrated so many things, but this particular video is just for MPLS traffic engineering. I'm not going to show you the complete configuration on each and every node because that would take a lot of time. What I have done is I have written 3 blogs on MPLS traffic engineering. I suggest you go ahead and look all those 3 blogs. Let me just open and show it to you. So this is the blog. These 3, as soon as you go to the home page, you'll see that there is one GNS3 Lab which says quick configuration MPLS traffic engineering. It has all the basic configuration, and let me just quickly open it and show you what it consists. So you see this, I have configured MPLS traffic engineering between PE1 and PE3. This is the MPLS tunnel between these PE1 and PE3 nodes. And in this particular blog, I have given a small description, a quick, small and brief description about MPLS traffic engineering and how it works, and few nitty-gritties here and there, and I have also explained. Apart from the good stuff is the configuration. You will find the complete configuration about PE1 and PE3 node, and then I have put up some basic verification as well here. So this is a very quick and crisp blog if you want to go ahead and configure MPLS traffic engineering. On top of that, if you want to go further, I have also written blog on link protection, FRR link protection, and also on FRR node protection. So in this video, my agenda is to show the basic working of MPLS traffic engineering, and on top of that I'll go ahead and give you demo about the link protection and node protection. You'll see how it is working in the topology. So let me quickly jump to my topology. All right, so let me just open the router. Here is my router PE1. On PE1 I have shown an interface tunnel 13. This is the tunnel configured as tunnel headed on MPLS traffic engineering. It has one explicit path configured. I don't have dynamic path on this right now. So I'll show you the explicit path. So this is the explicit path configured. The path is like this. I'll show you in the topology. So the red line, what you are seeing, it is the explicit path for the tunnel, and on top of that you see these legends are there. The primary path is the red one. The link protection path is the yellow one. So the traffic will go like this here, and from P2 it will get diverted to P3, and then it will go to P4. So basically on link protection, I'll break this gig 4x0 link, and we'll see how the link protection is working. And the node protection is like the green path given here. So I'll assume that P3 has failed, the node P3 has failed, and we'll see how the traffic is converging in that case. So let me show you other configuration on MPLS traffic engineering, what basically you need. So you need to configure one tunnel, You need to provide the traffic engineering explicit path, and then you also need to do some configuration in the IGP that you have. So I have OSPF as my IGP, and in the IGP I have these two commands added: MPLS traffic engineering router ID. You just need to put a router ID there, and then traffic engineering area. Apart from this, you also need to configure RSVP for signaling, and each and every interface in the path should have RSVP enabled. So I have this RSVP enabled, and then I have also enabled MPLS traffic engineering tunnels on this particular interface. And with this, this is almost complete configuration. You just need to enable traffic engineering globally as well with the command MPLS traffic engineering tunnels. So this command you need to put globally as well. Once you have it, you are almost done with the configuration. If you want to get into the details of the configuration, I suggest you go to the blog, and you have the complete configuration from the router. You'll get the complete picture. So similar configuration I have on PE3 also. Tunnel is 31. If you see, show IP interface brief, exclude unassigned. So you see this tunnel is working. 888 is the IP address of the loopback which is configured on this on PE3. You see this is the loopback. So this tunnel is unnumbered, IP unnumbered tunnel. It will get the IP address from the loopback, and that is what it is doing. So and the tunnel destination is 222, which is the IP address on this PE1, and IP address of the loopback 0 on PE1. So this is how it is working. Let me quickly show you some verification command. Show MPLS traffic engineering tunnel 13 is my tunnel. You see it is admin up, operational up, path is valid and it is connected. You also see that the shortest path to reach the destination is different, but I have the explicit path configured, that is the different path. And also in route record you see the labels are assigned, right? So let me just quickly show you what traffic I'm putting on this particular tunnel and how it is working. So I have two loopbacks configured. Loopback 1 is on PE1 and loopback 1 on PE2 as well. So between PE1 and PE2, I have put loopback traffic on the tunnel. How I am putting this traffic on the tunnel is with the help of static route for now. If you want to see that, let me just show run include IP route. You see this to reach 192.168.2.0, which is the loopback network on PE3. I'm taking tunnel 30. So this traffic is going over tunnel, and if you want to trace it, 192.168.2.1, you see the labels are assigned just like it is given in the tunnel verification command. So this label was distributed with the help of RSVP in MPLS traffic engineering, and this is the same path it is taking. So there is no other path apart from this MPLS traffic engineering. So with this, we can assume that our MPLS traffic engineering from both sides it is working, because I'm getting ping responses. If you want to trace from this side, 192.168.1.1, which is the loopback's IP address this side here, and let's see if it is taking traffic engineering tunnel or not. So here also it is exactly taking the explicit path which I have configured. You see the explicit path, right? So my traffic is going over the MPLS traffic engineering path, and I think with this we can safely assume that our MPLS traffic engineering is working fine between PE1 and PE3. The tunnel is up, and all the signalings etc. is are working fine because traces and ping is working perfectly. Now going beyond this, I'm going to give you demo on the link protection part. So let me just move to the link protection thing. So before that, I'll just explain a little that what I'm protecting and how the traffic will flow once the link is broken. So uh, in primary paths, traffic is going from PE1 to P1, and then it is going to P3, then it is going to P4, then it is reaching to PE3. Now, what happens if gig 4 by 0 fails on P1? So here on P1, we have one alternate path. Even if the interface gig 4 by 0 fails, I should ensure, because I am putting the explicit path here, so I must ensure that we have a backup path enabled on P1. So that is achieved with the help of link protection here. So on P1, I am going to configure one extra tunnel. I'll show you the configuration on P1. Let me just first of all do load login console. Show IP interface brief, exclude unassigned. So I have two extra tunnels here. One is configured, this tunnel 100 is configured for the link protection. Now, what is the source and what is the destination of this tunnel? So this tunnel is sourcing from P1 and it is going over this path. It goes to P2, then it comes back to P3. So this is P3 is the destination and P1 is the source of this particular tunnel, and this is providing us an alternate path to reach our destination even if the link gig 4 by 0 fails. So the traffic now comes like this, goes to P1 and then comes back to P3, then follows the previous primary path what we had. So let me just quickly present a demo for this to you. Let me just go ahead and shut down the link. Before that, I'll just ensure if I have all the configurations in place. To enable MPLS FRR link protection, first of all, you need to go to PE1 and check the configuration on the tunnel. So here we see that MPLS traffic engineering fast-reroute is configured. So we are good here. On PE3 you don't need to do anything, that is tunnel tail end for now. I'm not looking to protect the tail end path for now. So we'll go to P1 and see if we have all the configurations in place. We already have the tunnel configured. That was one necessary thing. I'll show you the configuration of tunnel 100. It is the description says it is link protection tunnel. This is also IP unnumbered tunnel. Destination is 666, and then it also has one explicit path which says that P1 to P3. If you want to see the explicit path, explicit I'm sorry. Okay, so P1 to P3, I'm going to 30.2 and then coming to 40.10. So this is these are the IP addresses assigned over these links. So this is the explicit path here, and I'm in on P3 also, which is the tunnel destination. You need to configure tunnels. So if show IP interface brief unassigned. So tunnel 100 is also configured here. Show run interface tunnel 100. You see that 444, which is the loopback IP address of P1, is configured as a destination. So both end on P1 and P3, I have a backup tunnel configured. for the back and forth path. And these tunnels are up, so if the primary link fails, the traffic should go over this backup tunnel. Let's see what else, I mean the third part of the configuration which is needed on P1 to ensure that link protection is configured fine. I'll just show you one more thing. So you need to go to show physical interface which is going to break, and specify the backup path here. So I'll show an interface. So here you need to specify that there is a backup path which is going over tunnel 101. I'm sorry, I mean this was previously configured. This is for the node protection thing. I'll just remove it. Interface gig 40, no. Yeah, tunnel 100 is for link protection. I'll write the configuration, and then we'll just shut down this link gig 40, and then we'll see what are the changes happening in the trace route. Before that, let's also verify if the tunnel link protection is in ready state. So show MPLS traffic engineering Fast-reroute database. Okay, so you see that on gig 4 by 0, I am actually protecting this path, and the tunnel is in tunnel 100. It is in ready state, and so we are good here. I mean, if the link fails, then this path would become active. The status here you will see as active, and then you should not see any traffic drop whatsoever. So let me just go ahead and do this. Let me just shut down this link. Okay, and now trace route 192.168.2.1. So this is the same IP address I did a trace earlier. This was the primary path which it was taking. Now let's see what path it is taking currently. All right, so here we see a little change. So if you compare 209, the was first level label, then 411 was second. Similar, 209 is first, but here we are seeing two labels. The 302 label is the label which is assigned by the tunnel, and we are preserving 411 because P3 is expecting 411 label. So when we reach P3, we still have 411 label on the packet. So P3 would recognize that packet because it has advertised that label earlier with the help of RSVP. So if you want to know more detail and a little more theory around it, I suggest you go to this blog and open this link protection blog, and I'll show you what else I have here. So apart from the basic configuration here, you see a little picture. It is also depicting that this particular link is failing and what path we are taking once the link is failing. So apart from the configurations, it also have some good verification commands, and some troubleshooting techniques also it is available here. So I suggest you go and check this particular blog. You'll get more idea about link protection. I'll just go back and move to the next demo, which is node protection. So I'll give you a small theory around it first. So now currently we are actually protecting this particular link. Now the backup path is going towards P2 and it is coming to P3. Now what happens if the P3 itself fails? You see there is chance that if P3 fails and we are taking this particular path, then we are not achieving anything. I mean, traffic was dropping earlier because primary path failed. Then we enabled link protection. Then the backup path was also coming to a node which failed. So we are eventually dropping everything, and there is no improvement at all. So we need to think a little ahead, and we need to have another alternate solution for this, and that solution is called node protection here. So what we are doing here, that if the link p3 if the node p3 fails, then the traffic should go from p1 to p2, and then it skips this link. It doesn't go to p3 now it goes to p4 directly. So for that, you might have guessed that we need to configure a tunnel between P1 and P4, which will act as a backup tunnel. The previous tunnel was configured between P1 and P3. That was tunnel 100. Now tunnel 101 is configured between P1 and P4, and that will act as a backup tunnel. I'll quickly show you the configurations on P1 and P4 for that particular tunnel. 101 is my tunnel. I'm not sure it has become a little slow since the time I have started recording. Anyways, so you see the tunnel destination, it is the loopback IP address on P4. Let me open P4 also. Show run interface tunnel 101. Okay, there's the IP address of P1's loopback interface. So IP interface unassigned. Okay, you see that the loopback here is 777, which is assigned as tunnel destination here, and yeah. So and the tunnel is also up. So now what I'm going to do is I'm going to configure node protection, and I'm going to shut down the link gig 40 again, because this is the only way. I mean, I have on GNS3 we have some restrictions. If I shut down this P3, I don't see the link on P1 is going down. It is still expecting. I mean, I'm not sure why, but it is still considering that gig 40 is up. So the node P1 is not able to recognize if P3 is down. So I can just right click and shut this particular router down, but that is not letting P1 know that P3 is going down. So to demonstrate this, I have to do the same thing. I need to shut down gig 40 again, but since I don't have link, I'm going to remove link protection and enable node protection here. So I would know that node protection is achieving what I want, right? So here I'll go ahead and change the configuration first on my tunnel. So I'll go to my tunnel 30, do show run interface tunnel 13. It has the normal link protection configuration. I'll just remove it and I'll put node protect. So my node protection is up. I'll just write the configuration. On P1, I'll do the same. Same thing what I have done for the link protection. So on gig 40, I had the backup path specified. I've changed that backup path. Interface gig 4x0. So now the backup path is over tunnel 101. Alright, show IP interface. Let me see if I have enabled it or not. I'll just go ahead and enable it once. Interface gig 4x0, no shut. Now let's trace and verify if our primary path is active or not. Okay, so it has taken a little time because just now the interface has come up. And now we see that our primary path is up. We are not seeing any backup label here. And the labels are changed. We have flapped the path, so that's totally fine. Now I'm going to shut down the link again and let's see if the node protection is working or not. Interface gig 4 by 0 shutdown. Let's see. All right, it has taken a very little time, although this is not very little. I mean, this can, for a vendor, this can be a serious issue. But again, this is GNS3, and things can be, things may go a little slower sometimes. So it's totally fine here. Uh, you see that we are taking the backup path, and now the path is going through 30 32, then it is going to 40 40 42. So basically it is following this particular path. 30 30 32 is here, 42 is here, then 52 is this. And we know that our backup tunnel, which is 101, is active. Here we are assigning one backup label also. In next hop, this is penalty made hop popping. So basically 301 is removed, and then the packet is sent with the original label 514 to P4. So, all right. I mean, I think here the node protection is also working, and this demo is kind of successful. If you want to know more detail about it, I again suggest you go to the blog, and here my first blog in the, I mean, the second blog here, I have explained the complete configurations, some nitty-gritties, and some troubleshooting techniques in this particular blog. So you go ahead, check this blog. You'll find it interesting. You'll find it useful if you are if you want to practice MPLS traffic engine configuration, node protection, link protection, and even if you want to troubleshoot it in your network. So it is very it is definitely, I hope it will be helpful for you. Yeah, let me just quickly show you if the tunnel path is active or not. So show MPLS traffic engineering Fast-reroute database. So whenever the primary link fails, primary path fails, and the backup tunnel becomes up, this is the very useful command which you should always use to check the status of the tunnel. So if it says it is in active state, then it is working. I mean, in the in the monitoring state, the status would be ready, as I showed you earlier. So in the working state, the when it has taken the ownership of traffic forwarding, in that state the status would be active here. So here we see that node protection tunnel is active, and with the trace routes we have also verified that the path is working fine. The traffic is over that backup tunnel, it is totally working fine. So here the demo completes. Thank you so much for spending time on my YouTube channel. I request you to like and subscribe and share this particular video. That would encourage me to make more videos like this. And thank you again. Have a nice day ahead, and happy learning.